subtopic.
Yeah, this is in continuation with vector field. See, uh, we studied vector field in last class. So, what exactly you learned from vector field? What is vector field? Anyone? Dave?
So the
Domain could be in R2 or R3.
so
Okay.
both the domain and range are in terms of vectors, right? Like
Okay. See, like for a layman to
a set of
understand,
vectors.
if you want to explain to layman who does not know the mathematics, see, what should I tell him about vector field? Is a flow of some substance, right? Vector field is nothing but a flow of some substance, maybe wind, electricity, or fluid, certain fluid. Okay, isn't it? It's a flow of some substance, right? So that's the vector field. Okay, now we are going to study about the characteristics of the vector field. Okay, so let's write down. Just a second. My pencil is not connecting. Turn on. Okay, fine. So just write down about vector field. What does vector field actually mean? So the vector field describe the flow of some substance, right? Maybe electricity, wind, or fluid. Okay. Now it has two characteristics. This vector field has two characteristics, that is divergence and curl. So what basically divergence mean? Okay, that we are going to learn today. What basically divergence and curl. So see, if you understand, like if suppose this vector field or some wind, let's talk about with respect to fluid. Okay, if fluid is flowing on the surface, okay, so at a point, see, divergence and curl are the characteristic of how flow is behaving. Okay, how this flow is behaving on a vector field. Okay, so divergence is basically, see, how this flow is behaving on a vector field. So with respect to one point, how it behaves around that point, around the neighborhood points. That is what the divergence and curl means. Okay, so divergence is basically the measurement of how much fluid flow enters the neighborhood. Okay, and like around neighborhood around a point P compared to how much leaves. Are you getting that? So you first write down what is divergence and like what's the topic is about. Divergence and curl are the characteristic of how flow is behaving on a vector fields in a small neighborhood around a given point P. Divergence is a measurement of how much fluid flow enters the neighborhood around P compared to how much leaves. So, like if you can understand this flow of vector field by considering any point on that field. Okay, so like considering any point and the how the vector field behave around that point. Okay, around the neighborhood of that point. So there are two characteristics of the vector field: divergence and curl. So what divergence mean is like it gives the measurement of how much fluids enter the neighborhood around point P compared to how much leaves. Okay, how much fluid leaves from that neighborhood. Got the idea here? See, this vector field is spread on xy plane. Okay, it's basically it's spread in three dimensional. It in three dimension also, right? So if vector field is spread, that vector field is considered as some substance that is spread out. Okay, that substance may be electricity, wind, or fluid. So if you consider like the how it behave, how the vector field behave, okay, that will be defined by two things: divergence and curve. Okay, and it behaves at certain point. What is the behavior of the vector field at certain point? So what divergence mean is how much amount of fluid is entering the neighborhood around the point P and how much fluid is, you know, is left that particular neighborhood. Are you getting that? How much fluid is entering the neighborhood around P compared to how much leaves around the neighborhood of point P. That is what the divergence mean.
What does
Yeah.
what does compared to mean? When they say compared to, does it mean like a ratio of sorts? Is it the difference, the
Yeah. Yeah.
ratio?
Yeah. I'll give you the formula for that. Like it's not ratio, it's just a number.
Yeah.
If number is positive,
Oh,
okay. See, if the amount of fluid leaves is more than the amount of fluid enters the
hmm.
neighborhood, it is positive divergence, right? See, divergence you can understand like diverging something. If the fluid is
Oh,
diverging
yeah.
more than the entering, okay, if fluid is entering the neighborhood around P is less than the amount diverges from that P around the neighborhood. Okay, that is what the that is called as positive divergence. It's just a number which will tell you about uh, whether it is positive divergence, negative divergence, or if suppose the amount of fluid enters the neighborhood around P is same as the amount leaves the neighborhood around P, then what would be the divergence? If both the amount are same,
Zero,
then
right?
the divergence would be
Yeah.
zero,
Zero.
right? And we have another case also,
Yeah.
that is when the amount of fluid enters is more than the amount of fluid leaves the neighborhood around P. Then in that case, the divergence is supposed to be
Negative.
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 Negative. Okay. So what the positive divergence means, like the positive divergence means what? The amount of fluid leaves more
More,
than the,
more is
yeah, more than the amount of fluids enters the neighborhood around 3. Okay.
that enters. Yeah.
And negative divergence means The amount of fluid
More
in
enters than
the neighborhood around P is less than the amount of fluid enters. So if the neighborhood gains fluid, okay, if the neighborhood around P gains fluid, then that is called negative divergence. Are you getting that idea here? If the neighborhood of
yeah.
around point P gains fluid, then that is called negative divergence. If it loses fluid, then that is called positive divergence. Okay, so let's
Got it.
summarize. Yeah, let's summarize that. So if more fluid or flow enters the neighborhood, then leaves it, then divergence will be negative at specific point P. Okay, it's a characteristic of vector field at specific point. Okay, at P. So this, like, we can summarize this as, you can think this as fluid or flow gathering at the point, right? Gathering at the point. That is called negative divergence. Now, if the same amount of fluid or flow enters as leaves, then the divergence will be what?
Zero.
Zero. Then the divergence will be zero at P. Okay. So there is certain term to this type of characteristics. Is called incompressive. Okay. This is called incompressive liquid. So incompressive liquid, it does not imply that the liquid cannot be, like, liquid is incompressible. It doesn't mean that. Okay. It's the characteristic of the vector field that is called incompressive. Got the idea here? You have a specific name to this. If the divergence is zero, that is called incompressive. Okay. So let's clear it out by writing the meaning of this incompressive. Incompressible flow, okay, that is called incompressible flow, implies that that density, okay, density remains constant within neighborhood of, within a parcel of fluid, you can write, within a parcel of fluid that moves with the flow velocity. So that is what the incompressive mean here. Incompressible flow does not imply that the fluid itself is incompressible. It does not tell that. Incompressible flow implies that the density remain constant, you know, around the neighborhood of a point P. Got the idea here?
Yeah.
because see, the amount of fluid enters the neighborhood, the same amount leaves, so density will always remain constant at that point, right? There is no gathering, there is no loss of fluid, right?
Hmm.
So now the third condition is, if more fluid if more fluid leaves than enters, then divergence diver divergence let me correct this spelling here. Divergence will be positive at P. Okay. So it diverging something, right? The diverging, the liquid coming out from the neighborhood around P is more than the liquid enters, right? So that is the positive divergent. You got the idea here?
Yeah.
Okay. So, like, let's talk about some terms here. How do we denote, how do we represent vector field? Capital F X Y Z is equal to Pi plus Qj
Oh,
I plus Q
yeah.
plus
plus Rk
RK,
cap.
RK cap.
Okay,
Yeah.
so it's a system of vectors that gives you all set of vectors that spread out on this in the space, right? So that's the vector field, and that is represented by Pi cap plus Qj cap plus Rk cap, where PQR itself a function of XYZ, right? Function which is maybe in XYZ altogether, right? So now what is this? Like, what is this?
Gradient.
Is it gradient? It's not gradient.
Gradient
It's
vector.
just a del.
Gradient vector.
No, it's just a del. Okay, del operator.
Oh, I thought you, no, I thought you were gonna complete it.
Okay,
I thought you were gonna write the full thing. So that's
yeah,
why.
yeah.
Yeah, six.
So we should always wait for the full question before answering, right? So this is just a del operator, right? If I just put small f after this, that would become gradient, right? That you know about that. So if this is just a del operator, uh, you will certainly verify that this is like the operator whose components are the partial derivative del upon del x I cap plus del upon del y j cap plus del upon del z k cap, right? So this is an operator here, right? Called del operator, right? If you like find the partial derivative of one function, just f, then this will give you the gradient, right? That would give you the gradient. Okay, but if you the divergence of f is the dot product of this operator with vector field. Okay, the divergence of f is the dot product of this operator, del operator, with the vector field. So what would be the, like, what would be the formula here now? See, this dot product is going to be, see, we always multiply the x components, isn't it? We always multiply the same component, the x component together, y component together, and z component together to find out the dot product, right? So this operator del by del x will be taken with the p, right? that would be taken with P here, del P upon del X, right? Plus del Q upon
yeah.
del Y plus del R upon del Z. Okay, so this is the formula of divergence of F. What is this? Is it vector quantity or a scalar quantity?
Uh,
Looks like scalar.
no, it could
Yes.
be vector also, no?
See, it's a dot product. Dot product will always give you scalar. It can't be vector.
Yeah.
But sir,
Yeah.
if the del p by del x, for example, is in terms of y and z, which it could be,
Yes.
right?
Yeah, it can be. It can be. So we simply apply the partial derivative with respect to x. The logic we know that has to be applied. Okay, if p is some function which has y and z to it, so if you find out the partial derivative, y and z has to be considered constant while figuring out the partial derivative with respect to x. Okay, that's the logic, that's the whole logic
Okay.
here, right? Since this del upon del x is the partial derivative,
Yeah.
if this if p, there are three different function here, right? P q r are three different function. If suppose we have same function, just f, it will give you the gradient. It will give you the gradient of the function, right? Here
Hmm.
there are three different functions, p, q, and r,
Right. Hmm.
which is coming out from the vector field given to you.
Got it.
You got the idea here? So this is the divergence of
Got it.
f.
Yeah.
It has to be scalar quantity because I said in the beginning, if it is positive, if the divergence of f is positive, what does that mean? This implies the amount of fluid
More
leaves
is
the
leaving.
More
neighborhood
leaves,
is more
more
than
leaves.
the amount of
More is
fluid
leaving.
enters the neighborhood, right? And
Yeah.
if it is zero, the like the same amount is entering, same amount as leaving. Okay, and if it is negative, what does that mean?
Density around the same.
Yeah, means if it is negative, there is a gathering of
Negative.
fluid around the neighborhood of a point. Okay, it's the gathering of a
Yeah.
fluid in the neighborhood around point P, right? That is what the mean. So divergence is this. Now let's talk about curl. So curl measures the tendency of fluid to rotate within neighborhood of a point P. Tendency of a fluid to rotate within neighborhood around point P. Okay, like can you the imagine where the some fluid is flowing. Okay, if fluid is flowing with constant rate, but there is some will. Okay, okay, so if paddle is there, if we can imagine a paddle which is along z axis. Okay, fluid is flowing on xy plane. If we can imagine a paddle which is along z axis. Okay, so the paddle can rotate. Okay, either paddle can rotate or it can stationary or it can rotate in other way around, isn't it? It's based on the characteristic of the fluid around the you know around the point. So what curl measures here? Curl measures the rotation of the vector field. Okay,
Tendency for, yeah.
it's a like its tendency of a fluid to rotate. Are you getting that? So let's measure the rotation of the vector field in the neighborhood around point P. So just write it down.
Yeah.
The measurement of rotation of the vector field in the neighborhood around P. Okay, so it's basically gives you the idea of like how much paddle spins. Can you imagine that paddle? Okay, so that measures like how much the paddle spins. Okay, so it's based on the the measurement called curl. So if suppose we have three types of curl again based on the measurement. If curl positive, if curl positive at a point,
Anti-clockwise.
yes, definitely. So since because the motion is angular motion here, right? Since the motion is angular motion,
Mm.
so if the motion is in anti-clockwise direction, then we consider that curl positive curl. Okay, so at a point, then the flow or fluid paddle would rotate counterclockwise. Okay, and if we have negative curl, so the rotation takes place clockwise at point P. Okay, all this happen at point P. If curl zero, if curl is zero, then
Paddle is stationary,
stationary, no rotation,
not not right. Yeah.
no rotation at P. So we can tell that irrotational vector field. Okay, now since we understood here that curl has to be vector, right? From this, from the idea of this curl, you can like imagine the right hand thumb rule. Hmm? If see this is the motion of, can you see that if this is the motion of your vector field, then what is the direction of the curl? Positive,
Upward.
going upwards, so in positive z direction, so that's the positive. It is anti-clockwise. See, my vector field is anti-clockwise. If my vector field is going clockwise, okay, then the direction of my curl is negative. It's downward, it's negative z direction. So this proves all the things which we have studied long before, right hand thumbs rules. Okay, so we can write the formula here. Curl of f is del f. What should I write in between? It's a cross product, right?
Yeah.
It's a cross product. So I cap, j cap, k cap. I should write operator first in the second row. Del upon del x, del upon del y, del upon del z. And what should I write below it? We have vector field f is equal to pi cap plus qj cap plus rk cap, right? So we should write
So PQR.
pqr. Okay, I have purposely written pqr in the third row because see, whenever we apply the, we find out this, right? When we find out this vector product, this partial operator like del operator, del by del x, has to applied on r, q, and p, isn't it? So it should apply on pqr likewise. If I would have written pqr in the second row, then this operator won't work properly, right? See, when you multiply it, when you start writing this vector product, so what we do, like, we cover up the first row and
You
first
find the
column, right?
yeah,
And
yeah.
we multiply this, isn't it? So del
Yeah.
upon del y
Yeah.
has to operate on r. That partial derivative has to operate on r with respect to y. That's why I have written this operator in the second row. Got the idea here?
Hmm.
Okay. Now let's uh, solve some question here. So exercise, we have one example in this: f of x y z is equal to minus x z. Okay, that's the given vector field. So we'll always have vector field in three dimension now, because we talk about electricity, wind, all these substances are in three dimension, right? It depends on what definitions or what functions are given to us. It has only z component, right? It has only z component, not z, sorry, y component. What is y component here in this? What is x, y, and z component in this vector field?
Uh, X and Z is zero. X and Z is zero.
Yeah, and only y component is given, which is minus x, right? So let's,
Minus x.
yeah.
Yeah.
So if you look at this vector field from the top of the z axis, since because this is independent on z, right? This vector field is independent on z component. So if you look at this vector field from the top of z axis, right, it's going to be same along the height. Are you getting that? This vector field, which can be projected on xy plane, that is going to be same along z axis, right? Are you getting that idea? Because it is not dependent on z, right? So if I try to draw the vector field on xy plane, since this is same along the height along the z axis, if you look at the vector field from the top of the z axis like this, okay, it seems similar at every height. Are you getting that idea here? Because it is not dependent on z, it is independent on z. So let's try to draw the vector field on xy plane, right? So we'll draw the vector field here on xy plane to understand it in better way. See, if it is dependent on z, then I would have to draw the vector field in three dimension, right? Since this vector field which is given here is independent on z component, there is no z component in this. So if you look
Yeah.
at this vector field from the top of the z axis, the vector field remains same. Are you getting that? It will look like similar at every height.
Hmm.
So therefore we can draw this vector field in xy plane to
Hmm.
understand the behavior of the vector field. So let's draw that. uh, okay, so how do we
If we
draw?
look at it from z, then we're not considering.
Sorry.
When you say look at it from z, you mean top view, right? Let's
Yeah,
say
top
this
view.
is x, y, and z.
Yeah, this is xy plane. You can see like this.
So that is anyway we can't, which means we can't see Z anyway, right?
Yeah, we can't see it is
When we look at
independent
something
on
from the
z.
top, we can't see that.
We can't see that what I'm telling you, no, that's why we are drawing the vector field on xy plane only, because it is independent on z axis.
Okay.
To understand the vector field, the behavior of the vector field, I'm drawing it on xy plane, whereas we no need to draw the vector field every time, because we know the formula
Yeah.
of divergence and curl, that's the dot and cross product, that's it. We can simply find out the dot and cross product. No need to draw vector field, because we cannot draw every single vector field, because if suppose the vector field is dependent on x, y, z, all all three components, right? So we have to draw the vector field in three dimension. That is impossible. Like, if we can, I can give you the picture of that vector field which is in three dimension,
Yeah, got
but drawing it's very difficult. Got the idea? But I'm trying that here because the given vector field is independent on z, so that you can have a better picture of about divergence and curl at least. Okay.
got
So at point P, what would be how? See, this vector field is basically have only y components, okay, which is nothing but minus x, okay. So it will always be parallel to, it will always be parallel to y axis, right? What is this? This is 1 comma 1, whatever, right? It is independent on the y coordinate, right? How would I draw the vector field here? So it is only dependent on x value of the given point. What's the, like, what are the steps to draw the vector field? We choose any random point
yeah.
and we plug that in the given vector field. It will give us the vector, the required vector, right? In which direction the vector is going, that will
So in
come to
this
know.
case, it'll be X.
In this case,
Yeah, it'll
if
be
we are
X units
selecting
down
1
the
comma
Y.
1, yeah, 1 comma 1, what would be my vector? That, see, the starting point is 1 comma 1. My
1
vector
comma
would
0.
be
1 comma 0.
minus j.
1 comma 0.
So minus j means this way,
Hmm.
going downward, right?
Yeah,
So at
Yeah.
every single point, right?
yeah.
Like, we just focus the x coordinate. What is x coordinate here? 2. That is going for the y component of the given vector field and reverse the
Hmm.
direction,
2 comma
basically.
minus 1.
Yeah, so this will be my
Yeah.
vector. Are you getting the idea here? If I take this point, this will go like this, 1, 2, 3, isn't it?
Minus 3 comma minus 2.
So 3
Hmm.
minus
Yeah.
3. So all vector field is parallel to y axis. Like, if you take this point, what is the x coordinate here? 1.
1.
So my
Yeah.
vector
1
would be
down.
like this, minus 1j. If I take this point, this will be my vector. If I take this point, this will be my vector, isn't it?
Mm.
Right? So to understand the behavior of this fluid, okay, behavior of this vector field, let's take any random point P here, okay, and we consider the small neighborhood of that point P, around point P, okay, the small neighborhood, okay. So this is the neighborhood of point P around it. So if you look at this, if I enlarge this diagram,
Mm.
if I enlarge this scenario around P, this is the neighborhood of point P. Okay, we always take the tiny neighborhood around point P. Okay, so this is the enlarged view of the neighborhood around point P here. So what are the how vector field behaving around this neighborhood around this point P is like here we are getting the smaller vector, okay, entering and leaving. As you go right of this, as you go in right hand side, as you move in right hand side, my vector field is increasing in length. It is becoming more stronger. Got the idea here, right? Towards right hand side, my vector field is becoming more stronger and stronger, isn't it?
Yeah.
Any doubt?
Yeah.
Okay. So, what should be the divergence? Any guess here? What should be the divergence?
0.
Zero.
Why?
Yeah.
Why zero?
Because what's the vector is like, as the mod of the vector, I guess, is the same going in and going out. Like it's the same
See the
amount.
amount of
Will we say
vector
symmetric
entering.
or
Yeah, the amount of vector entering the neighborhood of around point P is same as the amount of vector leaving it. Right? There is no gain or loss of
Yeah.
fluid around point P. Right? So therefore the divergence has to
mm,
be zero. We'll prove it. We'll prove it. That is what logic says here. The divergence is going to be zero. Right? What would be curl?
Hmm.
What would be the curl of this vector field? What should be the curl?
that mm, should be
See,
clockwise.
as
Should
you
be negative.
should be negative. What do you think there?
I think it should be zero.
Zero. See, what curl
Be-
measures?
because
Curl measures the
the
tendency of
rotation, right?
rotation of the vector.
So
Yeah.
they're all,
See, as you go,
but they're all
towards
straight,
right hand
right? They're
side.
not.
Yeah, all vectors straight. All vector are parallel to y-axis, no doubt about it. But as you go towards right hand side, the vector is becoming
Or
more
it's a straight
stronger and
person.
stronger. As you go away, like
Yeah, so
towards
it
right
should
hand
rotate like
side,
that. No?
the vector is becoming more
Huh.
stronger and stronger. So are you getting that?
Mm,
If the vector field is
mm,
more stronger, it will definitely rotate the paddle in clockwise direction. That's what logic says. We'll verify it. Okay. So curl, like
But sir, I
yeah.
thought rotation has to do with like the inclination of the this thing.
What inclination of
I
water?
thought it's like the slope of the vector, which, like the slope of the vector which causes the rotation.
Slope of the
Considered as
vector.
rotation.
Yeah, definitely. The slope of the vector is causing rotation here. No, this vector is pushing the paddle here. See, can you see that? If you just imagine a paddle perpendicular to at point P. Okay, if flow water is flowing, just imagine water is flowing like vector field is flowing here. If right hand side water is flowing with the great current, with the great power, then the left hand side of this, of this point. Are you getting that?
Mhm.
See, the right hand
Yeah,
side of this
yeah, I got
paddle is more having more strong current than the left hand side. It will obviously rotate the paddle.
okay, okay. I got it. I got it.
So let's try to verify this by the formula which we have here. What is divergence? What is divergence of f? That's the dot product of del operator with f. Okay. So
Yeah.
what is del operator? Del x, or the formula del p. Okay. Del p with respect to x plus del q with respect to y. No, it says partial derivative of r with respect to z, like that. So partial derivative of p with respect to x plus partial derivative of q with respect to y plus partial derivative of r with respect to z. So what is p in this case? Do we have p and r here? See, the given vector field is minus
No, it,
xj. There is no x component, right? Don't confuse with this x term. That's the y component basically. Okay, there is no x component. So partial derivative of 0 with respect to x plus partial derivative of minus x, that's the y component. Okay, with respect to y, and partial derivative of 0 again with respect to z. Now, do you know this, like del 0 with respect to x? What is
0
del?
plus 0 plus 0 is
Yeah,
0.
okay. So 0, and this is again constant since we are finding partial derivative with respect to y. So 0 plus 0 plus 0. So it came what we thought of, right? Now let's find out curl here. Curl of f. It should be negative, right? So let's find out the vector product here, which is I, j, k, del upon del x, del upon del y, del upon del z. What should I write in the third row?
0 minus x 0.
Yeah. So let's find out the curl. So del, like partial derivative of 0 with respect to y is 0. Partial derivative of minus x, right, with respect to z, that is also 0. I cap plus. Do you remember this multiplication properly?
Yeah, yeah.
Okay, fine. So
It should be
plus,
minus, right?
it should be minus, right? So minus,
Alter.
yeah. So partial derivative of 0 with respect to x, which is 0, minus partial derivative of 0 with respect to z, which is 0 here, j cap, plus. Now we hide first row and third column. So partial derivative of minus x with respect to x, which is minus 1, minus partial derivative of 0 with respect to y, which is 0, k cap. So it is coming like minus k cap. Okay, so curl of f is minus k cap. What does this mean? Have you thought of the same thing? The curl of f has to be negative. Did we get
Yeah,
negative here?
that's what I said.
Yeah, it's negative. Negative
Yeah,
means,
yeah.
negative means clockwise direction. So we guess it right,
Clockwise.
right? The clockwise direction. You can see
Yeah.
that. So the curl is going to be negative here in negative z direction. Okay.
Got
Now let's take the second example here. So f x y z is equal to x upon x square plus y square I cap plus y upon x square plus y square j cap. Okay. Now, can you imagine the vector field here? Since this is again independent on z, z component, there is no z component in this. So we can definitely observe this from top of z axis, right? From top of z axis, and we can have a sense. We can see the vector field that's spread out on xy plane, right?
Hmm.
So what would be the magnitude of each vector here of this vector field?
Will be one.
One. One.
One.
Yeah.
And have we done or have we like done such type of equation in the previous class where we have xi cap plus
Yeah.
Yeah.
yj cap? So what was the like the how the vector is going on xy plane? It is coming towards origin or it is going away from origin?
It was like a crisscross type of thing. I remember.
No, that one of the component is negative. Then we get what you are saying, like a tangent to the circle.
No, like
Okay,
Crisscross was before that.
let's try to figure out here. We know that the magnitude of the vector is going to be
oh yeah, yeah,
1
yeah.
always. Okay,
This one
so
was away from the origin.
away from the origin, right? Got the idea?
Yeah, yeah.
Away from the origin, and the magnitude of the vector is always 1. So like if you take point, if you take origin, let's say if you take 0 0, okay. Hmm? And if you plug 0 0, no, we can't plug 0 0 because that's not the part of domain here, right? You can't plug 0 0. That's not the part of domain here, isn't it? So
Yeah.
if you plug 1 1, let's say 1 1, so the magnitude of the vector is going to be 1 always, right?
Hmm.
Isn't it? The magnitude of the vector of this vector field is
Yeah.
going to be 1 always. So if you plug 1, so 1 over root 2, 1 over root 2 I cap plus 1 over root 2 j cap. See, x and y component are same, isn't it? X and y component are same. So it is exactly going away from the origin. At every single point, it is going away from the origin. Did you understand this?
Hmm.
Hmm? So that's the like you can draw a unit circle like this and another circle maybe which is again 1 unit apart from the inner circle. Does this look like circle? Horrible circle. So again, the vector is like going away from the origin, and each vector length is 1 unit like this. Okay. See, all these vector is coming from around origin. It's not coming from origin because we cannot plug 0 0. That's not the domain of this vector field. But one thing we can definitely be sure here that each vector is going directly away from the origin. Okay, and the magnitude of each vector is 1. Now let's take any point in this vector field, maybe somewhere here. Okay, and we'll draw the neighborhood of this point P. Can you see the small circle that represent the neighborhood of point P.
Yeah.
Okay. So let me enlarge it. Okay. So if you can think of the origin here, okay, from where like the vector field is emerging out, okay, like this. Now, can you guess the divergence of F here? Is it positive, negative, or zero? See, the amount of ray enters the neighborhood and the amount of rays leaving the neighborhood, are they same, or one of them is like, which one is greater?
Mm.
I think, I'm
Yeah.
not sure. There's more leaving it than entering.
Okay. What about you, Mano?
But um,
What you say? They have said that the amount of
We're talking about
rays leaving from the neighborhood is more than the amount of rays enters it. What do you say?
no, actually, no, no, no. It's the same. It's the same.
It's same.
So I think
lesser. Um, what enters has to leave, right? If it is,
It
if
no, no,
the
it's
neighborhood
not
is
like
less
that.
than one,
It's not like that. It's not like that. See, each vector field are
in this
separate.
case,
See, each vector field are separate, right? This vector field start here, it ends here. This vector field start here and here, right? It depends on the area, whose area is bigger.
hmm. Okay, 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 yeah.
See, think of the like electric field, no? Think of the electric field. Like, this is the electric field here. It's coming out from this point, okay? So it goes like this.
Hmm.
So this is the amount of electric field enters, right? And how much electric field leaves this neighborhood around point P, that depends on the area, right? So
Yeah,
the divergence is positive here, right? That has to be positive. It should come out as positive. Look at the arc length here. See, the arc length is, this part is more than this, isn't it? So based on that idea, or the idea of area, see, the rays is coming like entering into this the neighborhood around point P is that much area, has that much vector field only, and the amount of vector field is leaving from the neighborhood around point P has the bigger area than this. Okay, so obviously the divergence has to be positive. We'll verify that. We'll verify, but have an idea about this. What should be the curl? What should be the curl of F? Now always divide, to understand curl. Always divide the, this neighborhood into two equal parts,
hmm.
and then think of
No,
the,
no curl, no curl,
yeah, there is no curl,
no curl.
means the curl is zero in this case. Now let's verify this through the formula. Got the idea here?
Hmm.
Now onwards we are not
Yeah,
going to draw the vector
yeah.
field every time, because vector field may be dependent on all xyz components. so it's very hard to draw. If you want to draw, you can play around at home. So divergence of f is equal to del dot product f. Now del upon del x. What is the x component here? Have you written the vector field?
Yeah.
So what is y component?
Y upon root
Yeah,
of
plus z component is 0. So we'll find out the partial derivative of this x component with respect to x. So with respect to x, okay, with respect to x, we'll have to apply u upon v, right? Both has x here.
Yeah. Yeah. Yeah.
So x square plus y square. Can you do that by own? Root x square plus y square, x with respect to x is 1 minus x 1 over 2 root x square plus y square 2x. Am I right here?
Yes. Yeah.
Okay. Now x square plus y square, and then root x square plus y square minus y upon 2 root x square plus y square into 2y. So 2 will cancel out, and x square, okay, so x square plus y square minus x square upon x square plus y square root x square plus y square. Am I right here? Okay. Plus x square plus y square root x square plus
y.
y square x square plus y square minus y square. Okay. So x
Hmm.
square will cancel out, y square will cancel out. If you denominator are same, so x
Just
square plus y square will also cancel out. We are left with 1 over root x square plus y square. Okay, this is what? This is divergence, right? Divergence of f. What we thought of the divergence of this vector field. It should be positive. Did we get positive here? Is it positive? 1 over root x square plus y square. Can we say definitely that this is
Always.
positive?
always.
Yeah.
Yes. Yes.
Always.
Always. Because the square root will always give you
So
positive
I'll
value.
be back.
Like x square and y square both are positive basically. That's why we are getting positive. Sorry. Now we'll find out curl of f. So that's the cross product. Have you already figured out curl of f, Dev?
No, sir.
Okay, do that. I j k del upon del x del upon del y del upon del z x upon root x square plus y square y upon root x square plus y square 0. Okay, so partial derivative of 0 with respect to y is 0 minus partial derivative of this whole term with respect to z is 0 again because there is no z in it, I cap minus partial derivative of 0 with respect to x is 0 minus partial derivative of this term with respect to z is 0. So that's 0 j plus now partial derivative of which term? Yeah, this term with respect to x. Yeah, we have to calculate that, right?
So how did you get that to flow? It's del q del acha del q del z. Okay, okay.
Yeah.
Got that.
So
Mhm.
partial derivative of y over root x square plus y square with respect to x is what would be the partial derivative? Minus half 2x y. I've already figured it out, so you can write it directly. You can verify that. This minus this minus of minus half will get the same term x square plus y square minus 3 by 2 k cap. Okay, so if you observe both the term are same with minus sign, so everything will cancel or you'll get 0. So curl of f has to be
Yeah.
0 here, that we have thought of, so we get this exactly 0. Okay, I put up next example here. That's vector field f of x y z is equal to yz I plus xg j cap plus xy k cap. Okay, now there is no need to draw this vector field. We can directly apply the formula. Those two example was to that you to explain about, or you can imagine about curl and divergence through that example. So
Yeah.
divergence of f is equal to del dot f. We'll directly apply the formula here. So del with respect to x of p. What is p here?
Zero.
Wow,
YZ,
why is it?
which is 0.
Okay, they've said answer directly.
The whole thing will be zero.
Okay,
Yeah. Del by del x of YZ will be 0.
what is q? Q is xg. The partial derivative is 0 plus
Yeah.
r is xy and their partial derivative all are 0. So the
0.
divergence is 0. What does this mean? We have specific term to this. If divergence is 0,
Incompressible.
incompressive.
Yeah.
Is this mean the liquid is incompressive, or what does this mean?
No.
This means
Amount of entering and leaving is same.
The
the
density of the
density around
liquid
Density
around
body
remain
point
of the
P
liquid is the
will
same.
always same. Okay, yeah.
oh, yeah.
Let's find out curl of f. So del vector product with f. So I cap, j cap, k cap, del upon del x, del upon del c, yg, xg, xy. So partial derivative of xy with respect to y is x minus partial derivative of xz with respect to z is x again. I cap
This
minus,
is
you got 0? Okay. Y minus y j cap plus z minus
yeah.
z k cap, which is 0. So do we have any specific name to this? Did I mention that? If I have not mentioned, you can mention right now. Irrotational.
Yeah, it rotated. Mention.
Okay. Now last example here. Find divergence of f and curl f for f of xyz is equal to xy I cap plus xz j cap plus xy z square k cap at p minus 1 to 1. Okay, so this is the next question here. Now let's find out divergence of f. So divergence of f is equal to del dot f.
Tell.
Yeah, so god bless you. Partial derivative of p. What is p here? Xy with respect to x plus partial derivative of
One.
xg, which is y component with respect to y, plus partial derivative of r, which is xyz square here. Okay, so partial derivative of xy with respect
Zero.
to x is y. You got 0. How come?
Y. Y.
We'll find it
Y
out.
plus
Y
0
plus
plus
0 plus
0
with
plus
respect to
2,
z, so 2xyz.
2xyz. 2xyz. Yeah.
So divergence of f
Oh,
is
sorry. No, no, no. Minus two.
2xyz, and we have to find out divergence at certain point. What
They
is
are
that
given the
point?
point.
What is the point?
Becomes 2
Minus
plus
1 to 1.
One, minus
So
minus 2.
yeah, so
Minus 4, which
2
is
plus
minus
2
2 minus 4.
minus 1 2 minus 1, which will be minus 2. So the divergence is negative. What this imply?
meaning there's accumulation of the fluid at the
Yes,
point.
So you put one
yeah,
extra minus.
yeah,
Yeah.
gathering of fluid at certain point, at that point, minus 1 comma 2 comma 1, negative divergence. Let's find out curl now. Curl of f is equal to del cross f is equal to I cap j cap k cap del upon del x del upon del y del upon del z xy xg xyz square. So partial derivative of xyz square with respect to y is xg square minus partial derivative of z with respect to xg with respect to z is x I cap minus partial derivative of this xyz square with respect to x is yz square minus partial derivative of xy with respect to z is 0. Okay, plus now this, so partial derivative of xz with respect to x is g minus partial derivative of xy with respect to y is x k. Now we have to plug this point. We have to find out curl at specific point. Okay, so when we put that point, which is minus 1 2 and 1,
Okay.
so z1
So
1
it's
x minus
minus
1 plus 1 I cap minus y is 2 z is 1, so 2 minus 0 j cap plus z is 1 1 1 plus 1 1 plus 1 k cap. Okay,
two.
so
Yeah.
minus 2 j cap
Yeah.
plus 2 k cap. Okay, so this is
Two.
the
Yeah.
curl of f. This has to be a vector because this is the vector product. What does this imply? So if paddle align with this vector, if if the paddle is parallel to this vector, then it will have a maximum rotation, right? What would be the maximum rotation here? The maximum rotation is the magnitude of this vector, right? And the direction of this vector is like minus 2 comma minus 2j plus 2k. So it give you the vector. Are you getting that? 2 unit in j, negative 2 unit in j direction and positive 2 unit in k direction. So minus 2 2k, that gives you the vector. About that the paddle rotates. And what is the maximum rotation? The maximum rotation is magnitude of this curve.
So root 8
Root 8. Perfect.
to root
So
2.
yeah, so maximum happens only when the paddle is parallel to
Hmm.
this vector. So maximum rotation happens only if the paddle is parallel to curve of f. Did you get the idea here? See, this is my vector, suppose. Okay, if paddle is aligned along this vector, then it will experience the maximum rotation. If it like deviates from this vector, if my paddle makes certain angle with this vector, it won't experience the maximum rotation. Are you getting that idea? If the paddle is
Yeah,
exactly
got it.
along this vector, it will experience the maximum rotation at that point.
Hmm.
Okay,
Right.
so this is all about the divergence and curl. Can anybody like at least tell me the definition of divergence and curl?
Divergence is like a measure of how much um, amount of the fluid or flow enters and exits a particular neighborhood,
Yes.
and the this thing, what do you call it,
Tendency of fluid to rotate.
rotate around that neighborhood
Yeah.
about a point in time.
Yes. So divergence is measures the amount of fluid enters and leaves. Let's talk about that. Curls measures the rotation of the vector field around the neighborhood of a point. Okay,
Yeah.
that's it. Okay, so